Hello everyone. In this small video tutorial, we will be discussing section modulus in the context of beams. So this is a quantity represented by the letter Z, and it is given as the ratio of moment of inertia about the neutral axis divided by y max. Now I'll just explain what these things are. Now in the context of beam which is experiencing a pure bending, prismatic beam, that is, which maintains a constant area of cross section. So now let's say it has got a rectangular cross sectional area and of the width b and the depth d. Okay, now this horizontal axis is the neutral axis. Now section modulus is basically is a ratio of this moment of inertia about the neutral axis divided by y max. Y max is the distance of the farthest fiber from the neutral axis. So in this case, this distance y, it's going to be y max. It's being a symmetric cross section. The above fiber with reference to the neutral axis and the bottommost fiber are the same distance. So y max is going to be this much, as same as the below. Now let's calculate what is the mathematical expression for this in this case of a rectangular cross section. Now a moment of inertia about the neutral axis is going to be, the standard formula is 1 by 12 b d cube, and y max is going to be d by 2. It is half of the total depth, y max. Now just the ratio of these two will give us the section modulus for this rectangular cross section. That's going to be 1 by 12 b d cube divided by d by 2. It's going to be bd square by 6. Hence, section modulus for the rectangular cross section is bd square by 6. Now, what is the significance of this quantity? Now, the section modulus gives us an idea as to how strong the beam is against bending. So, higher the section modulus, so greater amount of bending moment it can sustain and keeping the stress levels low. So, our preference for the cross section is the one which has the highest section modulus for a given area of cross section. So it turns out it gives us the preference of the orientation of the beam and as well as the shape of the cross section. Like I'll just further extend this example itself. The orientation wise, we have to keep the z high, this quantity high. So if b is greater than d, the width is greater than the depth, so we have got two possibilities to keep the beam. First of all, like in the horizontal fashion, b and d, or I'll go to the next page. I think I cannot extend this way. Anyway, so I'll go to the new page. First, keeping the beam horizontally like this, keeping the width b here and depth like this, and the other way around, depth is this and b is this. So z in this case is going to be this a and this is b. So section modulus for the first case, as we have already calculated, it's going to be b d square by 6. And now the b and d quantity will switch in the second case. This is going to be db square by 6. This is b, this is a. So clearly we can see, since b is greater than d, so zb is greater than za. Section modulus in the second case, second orientation gives us a greater value, which means this orientation is preferred in beams as compared to the first one. So I think I can stop now. The next part will continue in the next video. Thank you.